Hello everyone, my name is Shruti Agarwal. My class is BSc third year regular. My roll number is 225056. My university roll number is 22103840100285. Topics I'm gonna discuss are the finite state automata, transition system, and the transition table. Now, finite automata. Finite automata can be represented by a 5-tuple Q, sigma, delta, Q naught, F, where Q is the finite non-empty set of states, sigma is the finite non-empty set of input alphabets, delta is the transition function which maps Q cross Z into Q. Cross is the Cartesian product. The Cartesian product of Q cross Z into Q is represented as this. Now mapping is usually represented by transition table or the transition function, which would be I discussing later. I will be discussing the formation of transition table and the transition system further. Q naught is the initial state and belongs to the Q, that is the finite non-empty set of states. F is the set of final states, which is also a subset of capital Q. Now, to understand the transition systems, and the transition table, let's take a daily life example, an example of a lift control. Now, suppose we have 3 floors, taking 3 floors, that is the ground floor, first floor and second floor, taking lift to be at the ground floor, representing by Q naught state. This is the state Q naught, initial state. If we press 0, the lift would remain on the ground floor on the Q naught state. If we press 1, the lift would be at the first floor, that represented by Q1 state. If we press 2, the lift would be on the second floor, that is the Q2 state. Now these 3 floors, ground floor, first floor and second floor, can be represented by 3 states, that is the Q naught, Q1 and Q2 respectively, and by input alphabets 0, 1, 2 respectively. Now we are taking ground floor as the initial state, Q naught as the initial state. So, now let's understand what is the transition system. Now, a transition system or a transition diagram is nothing but a finite direct labeled graph in which each vertex represents a state and the edges are labeled as input or output. Now, as we have taken 3 floors, here we have taken 3 floors, ground floor, first floor and second floor, representing the 3 states Q naught, Q1 and Q2. So we have here 3 circles representing the 3 floors. Now this inverted arrow which you can see here is representing the initial state. We have taken the lift to be on the ground floor, so the ground floor is the initial state. It is not necessary for the ground floor to be the initial state only. It is what I have considering. I have taken the ground floor as the initial state, that is why I have made the inverted arrow here. Now Q2, as you can see, I have made 1 circle in each of the 2 states but 2 circles in the Q2. Now these two circles represents the final state. I have taken Q2, that is the second floor, representing the second floor to be the final state. It is not mandatory to take the last step to be the final state. Initial state can also be the final state and this state can also be the final state. But this is what I have considered. It is what I have supposed. That is why I have made 2 circles on Q2. Now coming to Q naught, representing the ground floor. If we press 0, the lift would remain on the ground floor. If I press 2, the lift would go to second floor. If I press 1, the lift would go to first floor. Now if we come to first floor, if we press 0, the lift would go to ground floor. If I press 1, the lift would remain at the first floor. If I press 2, the lift would go to the second floor. Now, On second floor, if I press 2, the lift will remain on the second floor. If I press 1, the lift would go to the first floor. If I press 0, the lift would go to the ground floor. Now the 0, 1, 2, these are the input alphabets or input symbols, and these arrows are the directing agents showing the transition. Now it is not necessary for the source state to the transition state or the two states to be distinct. It can also be a self loop. Okay, so this is what the transition system looks like, and it is this, and this is the transition diagram or the transition system of this example. Now we make a table of the transition system. We have to make. So how we will do the transition? What is the transition table? The first question is this only. The transition table is basically a tabular representation of transition system. This table is made like this. These three representing these three states or the three floors, right? This arrow is representing that Q0 is the initial state, and this circle is representing that Q2 is the final state. The 0, 1, 2 are the input alphabets, and the 0 is representing the present state. This representing as next step, and this the inputs. Now Q0 0, Q0 input 0 gives Q0, Q0 1 input gives Q1, Q0 2 input gives Q2. Similarly, Q1 input 0 gives Q0, Q1 input 1 gives Q1, this, and Q1 input 2 gives Q2. Now Q2 input 0 gives Q0, Q2 input 1 gives Q1, and Q2 input 2 gives Q2. This is the transition table of this above transition diagram. Now Q is the set of Q0, Q1 and Q2. Contains elements Q1, Q0, Q1 and Q2. Now what was Q? Q is the finite non-empty set of states, and we have represented the states by Q0, Q1 and Q2. Right? We have taken Q0, Q1 and Q2 to be the three states. So Q is the set of Q0, Q1 and Q2 elements. Now sigma is what? Sigma is for finite non-empty set of input alphabets. We have taken input alphabets to be 0, 1 and 2. So it contains 0, 1 and 2. Q0 is the initial state. We have taken Q0 to be the initial state, and it also belongs to the set Q. F is what? F is the final state, and it is a subset of Q. F, we have taken Q2 to be the final state, and F is also a subset of Q, capital Q, as you can see. Now what is delta? Delta is the transition function which maps Q, Cartesian product of Q cross Z into Q. Now Cartesian product of Q cross Z, now Q contains three elements, and Q cross sigma. Oh sorry, this would be sigma, not Z. Q cross sigma, right? So Q cross sigma, Q contains three elements, sigma contains three elements, so Cartesian product of 3 cross 3 would be give 9 possible combinations. 9 possible combinations. So we have these 9 possible combinations. Delta Q0 0 gives Q0, delta Q0 1 gives Q1, delta Q0 2 gives Q2, delta Q1 0 gives Q0, delta Q1 1 gives Q1, delta Q1 2 gives Q2, delta Q2 gives 0, delta Q2 0 gives Q0, delta Q2 1 gives Q1, and delta Q2 2 gives Q2. Now this was all about finite automata. Thank you.